If you're watching this video, it's probably because you've overused your calculator too much in high school. And it is important to have a certain base of skill. We can't rely on our calculators for everything. As much as they're a wonderful tool, we have to be able to do some basic skills without using a calculator. So I'm glad you're taking the time to review rules with integers. What I'm going to do in this brief video is I'm going to go over a couple problems that I have listed here in front, and then I'll go over the ones that were on the self-quiz. So a couple of suggestions that I have. If you're struggling on integers, first of all, making use of a number line is a great tool. Second of all, I always encourage students to think about money. Money is very intuitive to us. So the first example, and this is probably, this type of subtraction problem is probably the most missed problem, right? I typically would get an answer of 1 or -1 for this exercise right here. But if you look at the number line, right, and you go to -3, which is right here, and then you subtract, right? So go to the left 2 spaces, and you can see that takes us to -5. I always called this the going more into debt problem, because if you think about money, if you have a debt of $3 and then you lose 2 more, right, you go further into debt. So students often will look at this problem and be confused about, wait, you're subtracting, but how come I added when you're actually subtracting? And down here I listed some of the rules. All right, so the rule for subtraction with integers is subtraction is the same as adding the opposite. So I can change the subtraction sign to addition as long as I change the number to the immediate right to the opposite. So the opposite of +2, because this said subtract +2, the opposite of +2 is -2. All right, and so I can change this problem to -3 plus -2. And then another rule that we should know is, in addition, same signs, add, and keep the sign. We all know a positive plus a positive is a positive. But if you have a negative plus another negative quantity, and I always described this as like, I'm in debt $5, my fiance's in debt $7, we get married, what's our financial situation as a couple? All right, and debt plus debt is a bigger debt. All right, so with the same signs, we add and keep the negative sign. The parentheses in this problem, and I say this kind of jokingly, but I always say they're just there for decoration. They're just there to separate the problem and make it look nicer. So sometimes students see parentheses and they think, oh, it means multiply. Oh, parentheses mean do this first, right? But the parentheses here are just separating off the negative sign to make the problem look nicer and neater. So that's why I say they're just here for decoration. So I'm contrasting this addition problem with the multiplication sentence, right? So here the parentheses do mean to multiply. And down here I have this set of rules listed, that a negative times a negative is a positive. It's also the same rule for division, right? Multiplication and division have the same rules. And then if one factor is negative and the other is positive in either order, then the result is a negative. All right, so this one would be positive 35. So continuing on with addition and subtraction. So in this exercise, again, if I wanted to use the number line, right? A number line is a great visual tool for those of you that may be more visual in the way that you process information. I'm at 5. I'm going to count back 16. That's going to take me to -11. Or I can follow the rule that subtraction is add the opposite. So this is a +16, right? This says 5, take away, +16. So if I change this to addition, I make this the opposite. All right, and then this gets me to this rule of, for addition, when the signs are different, take the difference. Okay, and then we take the sign of the number with greatest quantity or greatest absolute value. So again, think about money, right? This is $5 to the good. This is a debt of 16, right? Obviously, in the end, my result is going to be debt. And in this last example, so again, if I were to follow the rule about add the opposite, I feel like this is a rule that sticks in people's heads pretty well, that, oh, minus minus, that's plus plus. Sometimes it's nice to see why that is conceptually. I always liked to do these when I'm introducing this to students who don't know this rule. I'll always do the thermometer, and I'll do the example of, it's 7 degrees and then the temperature falls to -2. How much did the temperature fall, right? And that really helps students to recognize. So in other words, what's the difference between 7 and -2? And that really helps students recognize that from 0 to 7, that's a difference of 7. And then from 0 to -2, that's a difference of 2 more. Right? And that helps students to see that in order to find the difference between 7 and -2, when I count up these marks on the thermometer, right, I have counted 9 degrees, right? Or the temperature has fallen 9 degrees if it went from 7 to -2. So that helps give students a better conceptual understanding of why we get this rule of minus a negative is really add the opposite. Right? And I can see that on the number line if I say, well, what's the difference between 7 and -2? Right? Here's -2, here's 7. Let's look at the difference. It's 9 spaces. So let's take a look at the problems that were actually on the quiz. So same concept, just bigger numbers, right? Which sometimes makes it harder. But in this case, again, I go further into debt, right? I have a loss of 14, then I lose 16 more, or perhaps it's the easiest that I do this, right? Then I'm just adding 14 and 16 to get 30, right? But debt plus debt gives me more debt, right? So I get -30. Now, some of these other exercises require you to know order of operations. And when I write down the order of operations, you probably have learned PEMDAS, and I always write PEMDAS like this, parentheses, exponents, multiply, divide, I put them together, add and subtract, and I put these together at the same time. That is because multiplication and division, students often think you multiply first, divide second. Not the case, right? These go in the order that they occur from left to right. Exact same thing for add and subtract. All right, so I'm going to put quotation marks to show that this is brought down, right? We do addition and subtraction in the order from left to right. So if I have a problem like this. Right? Many students will think that this answer should be 1. They think, oh, multiply first, then divide. This is 6. 6 divided by 6 is 1, right? Not the case, right? I go left to right. All right, so I start here. This is 3. And then 3 times 3 is 9. Okay. So anyway, let's look at this problem then. So this does involve some order of operation. And I always encourage students to do one step at a time. You guys are a little more advanced than maybe students that I encourage to only do one step at a time. So maybe in this problem, we do need to start with the multiplication, but maybe at the same time I recognize that this subtraction could become add the opposite. So maybe I'll do that on the same line, but I have to make sure that I do my multiplication, which gets me -36. I have to be sure I do the multiplication before I do any adding or subtracting. Right? And now I've got an addition sentence. We know the commutative and associative property tell me I can do my addition in any order I want. So I'd probably put these two together first to get negative 39, right? Add 8. Well, the signs are different, so I will take the difference, which is 31, and 39 is a greater quantity than 8, so that's how I know it's negative. Now, when you see the problem written in this format, right, the fraction bar naturally forms parentheses, right? Put this in parentheses, put this in parentheses. Okay, so I do that numerator first, I get negative 14. Then in the denominator, right, I'd better do my multiplication first, so then I'll get negative 6 minus 1. And again, it's so common for me to see people say 5 or negative 5, right? But it's the going more into debt problem. If I have a loss of 6 and I lose one more, right, then I have a loss of 7. And then I divide. A negative divided by a negative is a positive. Okay, in the next example, I typed out the expansion of that exponent. I will occasionally, even in Calc 1, see students do silly things like this is 6, right? Because they multiply, all right? It's easy to be careless like that. So I expanded this out, and then I know a negative times a negative is a positive. So then if I have an odd number of negative factors, my resulting product is going to be negative, right? So I'm going to do my multiplication first here and get negative 8. Bring everything else down, right? So I haven't used my negative 3 yet. Bring that down. But here, I'm going to multiply these and get negative 10. And so I'm going to put it in parentheses for decoration, right, to separate off that negative. Sometimes students will say, well, I took this negative and I multiplied it by this negative and I got a positive. Technically, that is not following the order of operation correctly. But once in a while, what you'll notice about order of operation is if you can go out of order under certain conditions and still get the same answer. The problem is you don't always get the same answer that you're supposed to when you go out of order. So I encourage students to follow their, multiply first, then subtract, because this is saying subtract the answer to this, get the answer to this, and then subtract it. So I can do this, which people would say, oh, well, if I did negative times a negative, I still got positive 10. So again, you got lucky going out of order of operation, and sometimes that will happen. Now I have an addition sentence. I can do it in whatever order I choose. Because of the commutative associative properties, it tells me I can add in any order with any grouping I want. So I'll just go left to right. And signs are different. Take the difference. And the result is negative 1. Now, with the powers, couple things that I want to highlight here. Students will often confuse this problem with this problem, right? This says take the opposite of 1 to the 6th, right? 1 to the 6th is 1, right? The opposite of 1 is negative 1. Okay, whereas this is saying take the quantity negative 1 and multiply the factor negative 1 6 times. So as I mentioned, every pair makes a positive. Anytime I'm multiplying an even number of factors, even number of negative factors, I'm going to get a positive, right? If I have an odd number of negative factors, I'm going to get a negative, right? So this would be positive 1. The next exercise was negative 7 to the first, and that would result in an extra negative 1 up here, which would result in a positive 1 times negative 1. So I hope this quick tutorial helped you with any struggles that you may have been having with integers, and keep practicing. Force yourself to put that calculator down and work on some of these skills by hand.